We are going to begin section 6.6, frames and machines, and talk about pulley systems. What pulleys allow us to do is exercise some mechanical advantage. You may remember from physics, this is one of the simple machines. Perhaps in your own life you've used pulleys to help you do some work, but basically it allows you to put one force, which is a smaller force, and lift up a bigger weight, bigger than the force that you're pulling. So I'm going to use, so in order to quantify this mechanical advantage, I'm going to use a little technique called follow the P's. And what we're going to do is, the reason I call it follow the P's is if you look in textbook problems, often when you're pulling on something, it has a force P here. And in our textbook, I think we use P more than any other letter, so we're just going to call follow the P's. And in this case, it is going to be the tension around each side of the pulley. So if you remember, what happens with a pulley system? Pulleys are just changing the direction of the force. If you have a force P on this side, you have a force P on this side. If you pull that around, you have a force P on this side. So I'm just going to count the P's or follow the P's. I'm going to say that this is force P, that's force P, and force P here. If I look at what's happening down here, well, let's draw a free body diagram of that pulley. It has a force P going up. Remember, tensions always pull. You can never have a tension that pushes, so that means you have a P pulling up. And if you sum the forces on the Y, you have a 2P going down. All right, let's follow that around. So I'm just going to go back to my picture here. If that's 2P, following this around here, this is 2P. And then if I look underneath here, this must be 4P. Following this one around, I got 4P. Man, I keep writing B's instead of P's here. 4P. But then this must be 8P right down here. All right, what does that mean? It looks like it has a mechanical advantage of 8P. If I were to draw a little free body diagram of this weight, it has a weight going down, and it has 8P going up. If the question was, if P is equal to 100, what is the weight? Well, the weight would be equal to 800. And so that's what it is. That's the mechanical advantage of 8 in this pulley system. How about this one over here? I'm going to follow the P's around here. I got this. There's a tension in here. P going there, P going all the way around, and then this one is going to be P. If I draw a free body diagram, actually I'm going to just do a little method of sections right there, and then draw a free body diagram of what I've done. Let's draw that one. I have a weight supported by a pulley, and it's got 3 P's going up. Obviously a weight going down. So what is my mechanical advantage here? It's going to be 3. So I have 3P is equal to the weight. Now, how do I know that? Why is this one not counting, if you will? I got 4 P's if I look at it across here. But look, what's happening is only these 3 are pulling up on the weight. This one is just pulling down out of midair. And this one, it doesn't matter if it's pulling down or if it's going that way, or even if it's just going straight up like this. In other words, the only forces, the only P's that are holding up the weight are what you cut right above the pulley, right like that. So that's a technique that you need to understand, that only the forces pulling up on the weight count for our mechanical advantage. Let's see what we got here. Here's a man that's pulling up on or pulling down on a string here, and he's got a little pulley system that's going all the way around here. He's got 1,000 pounds here, and it says that he's not lifting it all the way off the scale. It says the scale still reads 500 pounds. So first of all, let's follow the P's. I am going to call this one P, and P, and P, going all the way around, then go on the inside and P. And now I'm going to cut it right here. Remember, P's always pull up, so I have all these p's here, which is going to be 5p. The weight or the 1,000 pounds is here, but the scale still reads 500 pounds. So really, where the scale is pushing up at 500 on that. So if I want to find out what those p's are, I could sum the forces in the y's equal to 0. And here I have 5p plus 500 are both going up, minus 1,000 going down is equal to 0. Therefore, p is equal to 100 pounds. And that's the answer that it was given right there. How about this one? This is a little bit different, and we got some fractions going on here, but let's say that we have a weight here, an mg, and it's got some weight going down. We want to find out what the proportion, I guess, of all of the tensions that are pulling this thing up. Well, let's look carefully here. There's a T here, and that would make this guy T over 2 and T over 2. I'm going to zoom in a little bit on this. If this one is T over 2, then this one over here is T over 2. If that one's T over 2, this one is T over 2. And if those two are T over 2, that means this is T. So I'll call that one T. And this one is T over 2, T over 2. If this one is T over 2, this one is T over 4. Same as there. If this one is T over 4, then this one is T over 4. Now this is symmetric on both sides of the center here, so that makes this one T and this one T over 4. And our question is what proportion, or what is T as a function or as a fraction of mg? So let's just sum the forces in the y is equal to 0 and see what I got. I got minus mg, and how many t's do I have? I got 3 plus 2t over 4, so, or 2t, well, whatever, 2 times t over 4, that gives me 3.5 t's. So if I want to know what t is, it's going to be 1 over 3.5 mg, which is actually equal to 2/7 mg, which is what the answer here from our book is. Well, here then I have a little exercise for you to try to do just a little bit of work. What we've got is a plate that weighs 100 newtons in all cases. And we want to find out the tension in the rope over pulley A. So this is pulley A. And we want to find out this tension. It'll either be that tension or this tension is going to be the same in all three cases. Interpreting the drawing, if it looks like it's tied to the plate, that's what that looks like. What we have here is this is a hole. So this is a cross section of a hole. So in this case, the rope comes up and over, goes through the plate without touching it. So obviously it's not supporting any weight at this point, and then tied to the floor. Same thing here. All right, so let's find out the tension in the rope in each case, and pause the video until you're ready to move on with some work. Okay, well here's the solutions. If this is 100 newtons going down, well, let's follow the P's first. This one is a P going up and over. This is our unknown. That's what we're looking for. That's P. That means P over 2, P over 2. So that gives me 2, or 1P plus 2 times P over 2. So that gives me 2P. Got 100 going down, so P is equal to 50. In this case, we got those P's, but this P isn't touching the plate. But here I have those two P over 2's. Plugging that in there, I got P is equal to 100. In this case, I got the P attached to the plate, but this P goes through, so I just have this P plus P over 2. So 1.5 P's, or P plus P over 2. Got 100 going down. P is equal to 66.7. Now here's a little what's the difference thought question, if you will here. Here I have a pulley. It's going up and around and around. If I were to cut my little cross section, it would look like this. Well, let's follow the P's first. I should do that. Let's go P, and then follow this around, P, follow that one to P, follow this as P, and then if I'm looking at what I've got here, I should have this as 4P. And remember, when we're doing this, it's only the forces pulling up on the system down here that actually count. This one down here isn't helping pull it up anymore. So then what's the difference here? If I were to pull this at an angle, wouldn't you expect, or wouldn't you guess that my little section is still going to be 4P? And indeed it is true. What I've got is pulling off at an angle doesn't help any, doesn't hurt anything either, but it basically doesn't matter. All this pulley up here is doing is transferring the direction of the force, and you could pull off at an angle, you could pull straight, or you could pull straight up, and you're only still going to get 4P, not 45 here, 4P on this side. All right, how about this next one? Here I have a P and another P. It follows that around. If I look at what I'm lifting up, I have 3P. Keep wanting to do that B for some reason. All right, 3P. All right, so that makes sense. How about this one over here? This one, I have a P and a P and a P. But this is interesting. This one has this force coming up at an angle. So is this helping or hurting, or is there any effect? Well, there is an effect. In fact, you have to kind of break this up into its components. If there is a theta here, this is going to be P cos theta, and then this would be P sine theta. So the cos theta component doesn't really help you pull up anymore, but this sine theta does. So if I were to look at cutting the section, then it's going to be this. This one would be the weight is equal to 3P. But over here, the weight, again, if this is the weight going down, the weight going down, the weight here is equal to 2P plus P sine theta. All right, so be cautious when you have something pulling off at an angle going up. In this case, coming down, the way this is configured, there is no sine theta or cosine theta that helps or hurt this part of thing. But in this case, it does have an effect.